Hello, all my Math 3 students. This video is for the Unit 1 practice test. I'm going to be walking you through each of the problems. I am making this video with the hope that you have already tried to do the practice test and that you are just coming here to check your answers and or get some I wouldn't say in-depth, but get some guidance on how to do the problems. As we go through, I am going to put a sign up. Sorry, I just need to make myself little. Like this, that tells you what problems that we're about to do, so that if you don't need to see me go through 1 and 2, you can just use the thumbnail at the bottom of the YouTube video. If you just drag over the play bar, the little dot, it'll preview what I'm doing in that part of the video, and you can just skip forward to the ones that you really need. Okay, so we are starting with 1 and 2. Oh, I should tell you one more thing as we get into this. Your actual unit test looks exactly like this. Same order, same number of questions. The only thing that is different is that the numbers will be different, but everything else is exactly the same. So really use this as your guide for what you are going to see on your exam. Okay, so when it asks us to find all of the factors of a number, we are going to go through starting at 1 and check to see what number 76 is divisible by. I always start with 1 in the number, so I'm going to do 1 in 76. Then I'm going to use my calculator and I'm going to check 2. Let me clear that out. So I do 76 divided by 2. So 2 and 38. And then the next number I check is 3. So 76 divided by 3. That doesn't work. 76 divided by 4. That works. 4 and 19. And because I have this table here, I know that I found all the factors. Typically, you would keep going until you got to number 19, because once you hit a number on the right-hand side, you're done. We're going to do the same thing for 84. We start with 1 and 84. The next thing that we check is 2. So we do 84 divided by 2. That gives me 42, so I write 2 and 42. 84 divided by 3. That gives me 3 and 28. So 3 times 28 is 84. Then I check 4, 4 and 21. I check 5. 5 doesn't work because it's a decimal. I check 6, 6 and 14. I check 7, 7 and 12. And because I'm out of boxes, I know that it's all the way done. Otherwise, I would go 84 divided by 8. That doesn't work. 84 divided by 9. 84 divided by 10. 84 divided by 11. 84 divided by 12. 84 divided by 13, 84 divided by, oh, I could have stopped at 12. I could have stopped at 12 because that I already had that written down. Okay, just to connect the dots, the reason that we have gone over how to factor a number is so that when you do problems like 5 and 6, you can use that skill to factor these trinomials. Okay, next up, we are factoring out a GCF only. So this means you are going to look at first and last term. I forgot to hold up our papers for those that are skipping ahead. So we are now doing 3 and 4. I have taught you guys how to do this by looking at the first and the last term. The first, if there's a number, you take it out. If there's letters on the end, you take them out. So the GCF for this problem that we're going to take out is 7x squared. That is not the answer, that is just the GCF. So we are going to divide each term by 7x squared. Why? Because that's the GCF that I'm taking out. I make sure to write this GCF as part of my answer. If you leave that off, you won't get full credit. 7 divided by 7 goes to 1, and that's what we wanted. We don't want a number to be on the front anymore. If you have 5 x's and you take away 2, you're left with 3, so x to the third. Notice we're taking the same exact thing out of the next term, so we keep the plus. 14 divided by 7 is 2. If you have 4 x's and you take away 2 x's, you have 2, so 2x squared. Keep the minus. Once again, we're dividing by the same thing because we're taking a 7x squared from each term. 28 divided by 7 is 4. X cubed, you take away 2 x's from 3 x's, you're just left with 1x. Keep the plus. 35 divided by 7 is 5. And the x squareds go away. That's exactly what we wanted. We wanted to factor this so that inside the parentheses there is no number on the front and no letters on the end. So we're going to follow the same process for number 4. If you haven't already done number 4 yet, you should pause the video and try it on your own, just so that you can verify you can do this on your test. But if you've already done it, then you can continue to watch. So we are taking out the 12 on the front and the cubed on the end. So GCF in this case was 12x cubed. We divide each term by 12x cubed. Now notice, we could have taken a 6 out of each term, but we want to take out the greatest common factor. And what I taught you guys in class was, if there's a number on the front, you always check that number. Most times, this number will come out. So instead of just going automatically to 6, you should check 12. I make sure to pull out my 12x cubed. 12 divided by 12 is 1. That's exactly what we wanted. If you have 5 x's and you take away 3, that gives you x squared. Keep the minus. 60 divided by 12 is 5. If you have an x cubed and you take an x cubed out, they go away. This is your final answer for 4. So first up was factoring a number. Then you're going to do a couple of GCF problems. Now you're going to do a couple of factoring trinomial problems. And remember, this skill we taught you so that you could do these problems. So now we are on 5 and 6. I'll give that little indicator for anybody needing to skip ahead. Okay, the first thing I do on these, and when you do this on the test, so let me look at you. Sorry, I'm still trying to look at you. I know that it's tedious for most of you guys to go through the trinomials like I'm about to show you, but when you do it on a test, you should just suck it up and do it the long way so that you can be sure that you get the question right. Sometimes if you take the shortcut and you just do it in your head, you make a silly mistake and then you don't get the credit. Whereas if you just would have done it the long way in the first place, even though it's annoying, you would have gotten the credit. Okay, I'm done preaching. So what I do is I split the second and the third term, and I list all of the factors of 54. So 1 in 54, 2 in 27, 54 divided by 3 is 18. I check 4. I check 5. I check 6. 6 and 9, and I know that that's going to be the last factor. This plus sign here tells me that I need to add all my factors. 55, 29, 21, 15. I am looking for a negative 15, but I have a positive 15, which means that I have to change every sign. So if I change the 15 to become negative, I also have to change the 6 to negative, and I have to change the 9 to negative. So this factors to x minus 6, x minus 9. This is the answer. Don't just say negative 6, negative 9. This is your answer. Okay, this one is slightly different because, there's a minus sign on the third term instead of a plus sign. So I'm going to list all my factors. 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, and that is all of the factors. This time I subtract them. So positive 1 take away 40 is negative 39. Positive 2 take away 20 is negative 18. Then you get negative 6 and negative 3. Turns out that the factors are 4 and negative 10. These match exactly. So you don't need to change anything. So number 6 factors to x plus 5 and x minus 8. Okay, let me put up our signs for what we're doing next. We're on 7, 8. So for 7 and 8, you need your pink card. This is going to help you do these the fastest. These are special binomials, and if it wouldn't have told me that they're special binomials, hopefully I would know that because they only have 2 terms. All special binomials factor down to 2 binomials. One is a plus, one is a minus. So I can do the same for this one right now. All I have to do is root the first term and root the second term. That's why these are special binomials. I can go to my pink card. The root of 121 is 11. The root of x squared is x. So in my first term, I have 11x because that is what is in my first term in the problem. In my second term, I have the root of 144, which is 12. I put that in the second term in my binomials. This is your final answer. Notice there are no roots in your answer. You only use the roots at the beginning of the problem, not once you find the factors. This has a typo. This should be 625. So now that I fixed that, if you haven't done this problem already, you should probably pause and do it. It's the same method. You root both terms. 625, the root of 625 is 25. Root of x squared is x. Root of 49 is 7, but this time we have a plus sign. And remember, when there's a plus sign, you have to add on those imaginary numbers. You have to put an imaginary number on the end. Otherwise, if you multiply it back out, it doesn't equal 625x squared plus 49. Okay, 9 and 10. So extra special binomials are extra special because you are going to end up with 4 binomials. Notice that these are x to the 4th. That's what makes them extra special. So just as a heads up, your final answer is going to look like this: plus, minus, plus, minus. You can do the same for this one. 1, 2, 3, 4. Plus, minus, plus, minus. Okay, you start the same. The root of 250, this starts out as 2 binomials. The root of 256 from my pink card is 16. The root of x to the 4th is x squared. The root of 625 is 25. And now you have 2 special binomials. So you start with an extra special binomial and you get 2 special binomials. So now just to kind of color code these, this first binomial is going to turn into those 2. Our second binomial is going to turn into those 2. So I root the first term, root the second term. Root of 16 is 4. Root of x squared is x. Root of 25 is 5. And this is a plus sign, so you need to make sure that you include the I. Then we do the same here. Root of 16x squared is 4x. Root of 25 is 5. Notice that none of the binomials are the same. You have a 4x, 5i, plus and minus, a 4x and 5, plus and minus. So they look the same, but they're not exactly the same. You have 2 imaginaries, 2 regular. This is going to end up being the same. So even though it doesn't look like it is an extra special binomial. It only has 2 terms, and it's an x to the 4th. So the first time I factor it, I'm going to get x squared plus 1 and x squared minus 1. Then when I root these 2, I'm going to get x plus 1i, x minus 1i, x plus 1, x minus 1. So before we finish up, I just want to zoom out and I want to remind you that on your test, you will have 2 tables, 2 GCF only, 2 trinomials, 2 binomials, 2 extra special binomials, and then lastly, you're going to have 4 that tell you to factor completely. Anytime a problem says or asks you to factor completely, what that means is that you need to look for a GCF first and then factor. Sometimes there might not be a GCF, but you want to double check. After you take the GCF out, you look at the number of terms in order to decide how to finish the factoring. So, number 11. Oh, I didn't put my sign up. We're doing 11 through 14. Okay, so we are going to take out a GCF first. I have a number on the front, but no letter on the end. So my GCF this time might be 8. I'm saying might be because we need to verify that 72 is divisible by 8. It is. So I'm going to divide 8 off of the first term and 8 off of the second term. This is going to give me 8 as my GCF, parenthesis, x squared minus 72 divided by 8 is 9. Then the next thing I do is say, okay, is this one where I list all the factors and add or subtract them, or is this a special binomial? This is a special binomial. You can keep going. So you would root x squared, you would root 9. Make sure you keep your 8 on the front. So this becomes x plus 3, x minus 3. Next up, we ask ourselves, is there a GCF? Well, there's a 2 on the front and an x on the end, so we're going to need to take those out. We're going to divide each term by 2x. You must actually write out the resulting trinomial. You have your 2x on the outside. Now be careful to divide out a 2x from all of these. Okay, I ran out of storage space. Sorry about that. So 2 divided by 2 is 1. If we have 3 x's and we take one away, that leaves us with x squared. Keep the plus sign. 22 divided by 2 is 11. If you have 2 x's and you take one away, you're left with x. Keep the plus. 56 divided by 2 is 28, and the x's go away. We have 3 terms this time, so this is one where you list out all of the factors. 1 and 28, 2 and 14, 3 doesn't work, 4 works, 4 and 7. The plus sign means you add them. You get 29, 16, and 11, and these match exactly. You're looking for ones that add to 11. This one does. So your final answer is 2x, parenthesis, x plus 4, x plus 7. So number 13 now is going to be very similar, and your final answer is going to have a GCF in the front and 2 binomials. I want you to solve this one out without me. So pause and do it. I'm not going to describe what I'm doing. I'm just going to do it, and then you're going to check your answer against mine. Okay, there's my final solution. You're just making sure that yours matches mine. And now we're at our last question. So we're supposed to see if there is a GCF. There's no letter on the end, but there is a number on the front. So we're going to see if the GCF is 9. we go over and we say 64 divided by 9. That did not work. So it turns out there is no GCF. Okay, well, it's only 2 terms. If I go back through this review and I look at what I did when the problem only had 2 terms, I took the root of each one. So this turns into 3x plus 8, 3x minus 8. So that's it. That's the whole shebang. But one last thing. I want to make sure that you are prepared for all kinds of GCFs. So notice, you could have a GCF that's a number and a letter. You can have a GCF that's just a number. Or you could have a GCF that is just a letter. So for this particular problem, your GCF would be x cubed. If you took an x cubed out of each term, that would leave you with x squared minus 10. So just know that when you take your exam, some of you guys are going to have a GCF that's just a number. Some of you guys will have a GCF that's just a letter, and everybody will have problems where the GCF is a number and a letter. Okay, that's really all there is. If you need to study, please study. Otherwise, good luck on your test.